basic system requirement. Look up an order status in a database and send a confirmation email to the customer. The current industry instinct is to build an autonomous loop for this. You give a large language model a set of tools, prompt it to figure out the steps, and let it run. Because the model has to reason about its next action at every node, the system burns thousands of tokens, incurs massive latency, and fails roughly a third of the time. This chart shows the baseline success rate of a single deterministic script juxtaposed against a multi-step autonomous process. A single function call succeeds 85 to 90% of the time. Over a 10-step process, compounding errors drag that success rate down to 35%. The mathematically optimal architecture for any software system is always the lowest level of abstraction capable of completing the task. The term agent does not mean a smarter or better AI. An agent is a specific, highly variable control flow with an enormous execution cost. Autonomy is a budget you spend, not a default state. Deploying a free-running reasoning loop to fetch a database row is like buying a self-driving car just to walk across the street. Every AI architecture relies on a single defining metric: who holds the map and orchestrates the sequence of steps. In developer-controlled flows, the logic path is hard-coded. The system moves from step A to step B exactly as written in the code. This table breaks down the shift to model-controlled flow. In an agentic architecture, the AI dynamically decides the route, computes its own loops, and determines when the job is finished at runtime. Handing over the control flow alters the physics of your application. You trade predictability for flexibility. As you rely on the model for routing, the cost per execution rises, response latency multiplies, and the number of available failure vectors expands with every decision node. To manage this trade-off, companies like Anthropic use a strict three-rung ladder to evaluate how much autonomy a task actually requires. Mastering this axis of control separates brittle experimental prototypes from robust systems running in enterprise production environments. The bottom rung is a single tool. One model evaluates the input, makes one decision, and executes one function call. Checking the local weather, looking up a stock price, or converting a currency are native fits for this rung. This decision tree flowchart outlines the logic. If one function call answers the prompt, you use a tool. This structure provides a baseline reliability rate of 85 to 90%. Under the hood, the vast majority of shipped software features marketed as AI operate exclusively on this bottom rung. Wrapping a one-shot job inside an autonomous reasoning loop slows down the response time and multiplies the API costs to achieve the exact same result. The single tool call is not a starter level. It is a permanent architectural necessity for millions of discrete operations. If a single execution resolves the user's intent, engineering discipline demands you stop there. You step up to rung 2 when the task requires multiple discrete operations, but you already know exactly what those operations are. This is the chain or workflow pattern. It operates like an industrial assembly line, moving raw data through a fixed sequential series of processing stations. The engineering payoff is absolute determinism. A chain executes identically on every single run. This diagram shows a multi-step workflow. Because the path is rigid, compliance teams and highly regulated finance sectors mandate this structure for auditing and reproducibility. The vulnerability of a chain lies in its rigidity. If an input behaves outside the expected parameters, the predefined route breaks. A failure at the extraction node strands the downstream validation step. The system cannot calculate an alternate route. The diagnostic question for rung 2 is straightforward. Can you map the exact flowchart on a napkin right now? If you know the recipe, you own the map. The model cannot get lost, but it also lacks the ability to navigate around sudden roadblocks. The top rung is the autonomous agent. The core mechanic shifts here. The model runs in a continuous loop with access to tools, evaluating the real-world output of each action to dynamically choose its next step. This flowchart illustrates how the agent adapts. When the initial extraction fails, the model recognizes the error, replans, and reaches for an alternative method like OCR. Runtime judgment is required for open-ended inputs where you cannot know the necessary sequence of actions in advance. If all autonomous options are exhausted and the result remains unclear, the loop concludes by escalating the issue to a human. This flexibility carries a massive computational bill. Context windows swell, token burn rates surge, and latency compounds with each recursive pass. Errors in a loop are compounding. Every dynamic step inherits the hallucinations, malformed data, or failures of the step before it. The standard constraint for agent design is to keep the execution loop on a tight leash, ideally restricting it to fewer than 5 calls. An agent is an emergency capability. You deploy it strictly when deterministic logic cannot handle the variance of the input. A production software application does not exist purely on one rung of this ladder. This animation illustrates the reality of modern enterprise architectures. They are hybrid systems, weaving rigid workflows with targeted flexible nodes. In the routing pattern, a fast classifier acts as a gatekeeper. It pushes predictable requests down inexpensive deterministic chains and only routes messy edge cases to the heavy agentic loop. Alternatively, an agent can be nested inside a chain. You lock down the surrounding logic and delegate a single unpredictable step to an autonomous model. This full decision tree shows the complete diagnostic path. You ask the 3 questions, moving downward and justifying every step up in complexity. The architectural ideal is a highly testable shell of determinism surrounding the smallest core of autonomy. Do not deploy an autonomous agent for a job a single tool call can accomplish. The correct architectural choice is almost always a lower rung than your ego desires.